Welcome back. Our next speaker is Professor Dr. Martin Schulz. Martin Schulz is a full professor and chair for computer architecture and parallel systems at TU Munich, which he joined in 2017, as well as a member of the board of directors at the Leibniz Supercomputing Center. Martin?
All right, so I think now I'm set up. Hopefully you can see the slides and you can hear me and you can probably see me too, even though I can't see myself. So thank you very much, Samir and Mike, for the invitation. I'm happy to talk today on some of the European activities. That's what Mike asked me to talk about. Samir, I can't see the chat right now, otherwise I would not see my own slides. So if there's anything on the chat, feel free to chime in and we can also take questions interactively.
Yes, of course.
So as Samir said, I'm Martin Schulz. I'm at the University of Munich. I'm also one of the directors at the Leibniz Supercomputing Center, which is one of Germany's top tier, one of the 3 top tier centers. We're currently hosting SuperMUC NG, which you probably see behind me right now. There's some exciting news out of Europe. We have a new set of projects starting up, and I'm kind of involved in several of those, and think their scope and topics match really closely with what we'll be talking here. In other words, I heard Mike talk about this morning about what's going on in the E4S, and so I think it's great to kind of start this conversation early. There's going to be I'm going to apologize right ahead of time a bit the unspecificity for this talk, but it's going to be about new projects, and so there's very little particular concrete results yet. But I think the direction is very exciting, and I'm looking forward to forming some connections here with the E4S, and hopefully we can work together on some of these topics. So if you look at what's happening in Europe, if you've seen over the years, there's been a long history of very successful EU projects in HPC, and a lot of tools and applications and software environments came out of that. They were run through EU programs like Horizon 2020. There's also been a lot of funding from the member states individually. Germany had a very successful program called SPXer, that developed technologies for the Exascale timeframe, but they always kind of have been running independently. And I think the same thing happened in what happened in the US with the ECP project. It was the idea to create a more integrated program to really bring these threads together and to develop an exascale ecosystem and an extreme scale ecosystem going beyond exascale that brings out some of the European technologies. There's a somewhat European focus, but it's also heavily on the D side. So some research still, but having a development side to make this work. And that's kind of where EuroHPC comes in, which is an entity actually that supports this program. So since in Europe, it's not quite as easy as sometimes in the US when you have one country and one organization behind it. We have a lot of the different member states in the EU and outside. So bringing them together required a legal entity. So EuroHPC is not just a program, but it's an agency. It's also a funding agency that provides funding to drive these projects forward. It's a total of 32 participating states, plus the EU, plus a few private members, and a budget of about from 2019-2020 of 1.5 billion euros, which is partially supported by the EU and partially by the member states. So there's a kind of a mixed funding going forward on these things. If you're interested in more details, there's the URL down here, and you can look up some of the more details of that. Here's an overview of these EuroHPC member states that you see on the top left here. So all the states that are in color are participating in the EuroHPC, so have paid some funds into that and are participating in projects and are co-funding some of these projects. So you see an overlap with the EU, but it's not all of the EU and not all states are in the EU. So it's kind of a mixture. It's not directly coupled to the EU, but it's very dominated by the EU states, obviously. And as one part of this work, there was already some funding announced for some major compute infrastructure. And you can kind of see there's a total of 8 systems funded all across Europe. There's a couple smaller petascale systems which are marked here in blue. But then more interestingly, for the scaling part, there's 3 large scale so-called pre-exascale system funded, one in Barcelona, one at Cenica in Bologna, and one in Kajaani in Finland by CSCS, the LUMI system. And those systems are in the order of 200 petaflops each. So those are kind of the first large-scale system that get us really close to the exascale timeframe. And obviously EuroHPC plans on going forward and funding exascale machines as well at other member states, but that is still to be determined. So this is the current state of things. So there's an infrastructure funding here, but then there's also a lot of funding being put into putting the exascale software stack in place, putting the applications in place, and also making sure there's the appropriate skills and that are needed in Europe to kind of drive this HPC ecosystem. And so here's some of the activities. So I got these slides from the European Union. That's also why I have the logo on the bottom, just to give you an idea what this EuroHPC Joint Undertaking (JU) is up to. So there's some work right now that they want to point out, which just goes on, of course, the COVID-19 research. So EuroHPC is coordinating some of that together with PRACE, which is a kind of a body similar to Exceed in the US to kind of give out cycles to academic researchers on these machines. There's also cooperation with Exceed on the kind of activities on how to organize these cycle calls and to make sure that researchers get the necessary cycles to run the experiments. I already mentioned the procurement of the 8 supercomputers, 3 of these pre-exascale systems that are currently being stood up and should be announced. Some of them may have been announced, some will be announced soon, and they will go up and be running soon. And of course, and also working on the access conditions on how to get onto these EuroHPC machines. So it all plays into the mission to establish, that is again taking both from the European Union, an integrated world-class supercomputing and data infrastructure and support a highly competitive and innovative HPC and big data ecosystem. So it's not just HPC, it explicitly includes the big data as well, and some of the artificial intelligence needs on the HPC side as well. And as part of that, as already mentioned, the EuroHPC JU is not only a program, it's not just an organization, but it's also a funding agency. So as part of that, puts out calls for funding that researchers over Europe, typically in large consortia, can apply. And there's been a whole set of calls this year for these particular work programs that have been gone out. And some of them that have already been decided and are in the process of being funded right now. Get to that in a second. But there's kind of starting to form a lot of activities in Europe around these calls and around these programs and projects that come out of these calls. So here's some of the topics that were already in these calls. So there was a whole series of calls for extreme scale computing technologies. This is kind of the match with the E4S. So this is some hardware, but a lot of software methods, algorithms to kind of build the software stack to run on these technologies. There's a lot of work on HPC applications to kind of ensure that European applications are ready for this time frame. And there is, and some of you may have heard of this already, the European Processor Initiative that was initiated a couple of years ago to build a European HPC processor to kind of build a more independent European ecosystem, which is an ARM-based processor. At least that's the idea, together with some RISC-V accelerators, so some open source hardware parts there as well. And there's being stood up a commercial company called Cypearl, which is headquartered in France, but also has a second office now in Germany as well, which is starting to produce and market this European processor. And that will be out in the next 1 or 2 years with the first version of that. And of course, there's a timeline going forward on this as well, which will be ARM-based, and then some accelerators to be added, but that's to be decided. So that's kind of exciting as well. And a lot of these programs, of course, play on that. And there's supposed to be an ecosystem around this processor initiative, but not excluding others. Well, they will really build a large-scale system that we can rely on when we stand up these large systems. There's also programs for 2 pilots and 2 demonstrators, which have just been closed, those calls. So those are under review right now. There's supposed to be 2 exascale pilots with new technologies around the EPI processor. And also the European Union is looking with EuroHPC already in the quantum timeframe. So there will be also one quantum system pilot being stood up as well. And also to be looking, of course, there in the integration with the HPC ecosystem. And last but not least, there's also a set of centers of excellence being stood up in multiple member states, also co-funded by EuroHPC. Also those have already been awarded, and they should be made public really soon there as well. So what I want to focus on here is, as I said, the first call. This is the kind of where the projects work in the European software stack on the extreme scale computing technologies. And this is taken verbatim again from the call. Just a specific challenge to develop world-class extreme scale and energy high efficient computing, high performance computing, HPC and data-driven technologies that use software engineering techniques, programming tools, libraries that can be adapted and retargeted to rapidly evolving HPC architectures in view of maximizing application performance and efficiency in next generation supercomputers. I know fairly vague, but I think it kind of is just is a very, very similar scope than what we have seen with the ECP project in the US, with the software efforts in Japan around Fugaku, but also what we heard from Mike this morning in the E4S scope. So this fits kind of together, and so that's kind of where I'm hoping we can go a little bit there into the collaborations. As part of that, they were called out several areas. There was a set of calls on node level technologies, particularly focused on energy efficiency. There was particular calls for I/O system, advanced scalable networks, programming models, runtime systems, and system software, and then a separate area for mathematical algorithms that are targeted towards scalability, and then another set of calls at particular targets at high efficient solutions on high impact applications. So I actually wanted to talk a little bit about the ecosystem and which projects have been funded, because those fundings have been basically been decided on. So we have 9 new projects in the first 5 areas and 5 projects in the energy efficient application area. And I was actually hoping to give us a kind of an overview, but the system of Europe kind of didn't allow this. So these things have been awarded, but there's still negotiations going on, contract negotiations. You have to imagine we have in these projects between 10 and 20 partners from different countries with different legal systems, and the European Union as another partner. So there's been a lot of negotiations still to set up these projects. That's something I had to learn as well, coming from the DOE before, where you had one funder and everything else was taken care of. So this is kind of a little bit of a drawback here of the diversity, but hopefully these things will be done soon. These projects are actually slated to start in early next year, and so we'll see all these projects out and doing their own advertisements. Hopefully by the time January, February rolls around, we'll actually have a complete overview. So, but I know there has been projects awarded in all of these areas, so we're going to cover the complete software stack with these projects. There's an explicit mandate between these projects to work together and to form a single software stack, and with that to really advance the software ecosystem. So what I decided for this talk then is to talk so simply about the projects that we are involved in. We are involved in 3 of these projects, one in the programming models runtime area, one in the algorithm area, and one in the area of the energy efficient solutions for high impact applications. And 2 of those are also together with the Leibniz Compute Center. So again, these are large projects with a large number of partners. Now I'll give a quick overview of these projects at least, so you get a flavor of where we're heading and what kind of targets we have, and that hopefully by early next year you'll see the full spectrum of these projects going forward. So the first project is called Deepsea. Deep stands for Dynamic Exascale Entry Platform. This is kind of almost a historical name at this point. The JSC, the Jülich Supercomputing Center, has been leading a whole series of these projects since 2011. Over the deeper, deepest, and now Deepsea, building up the ecosystem on the hardware and on the software side. So this is the latest incarnation of the series of projects. And C in this case stands for Software Exascale Architecture. We have a total of 13 partners in there from 8 countries. Again, this is a large effort led by Jülich, and also dissemination activities led by LRC. So all the PR you're going to see gonna come out of the LRC. Here's an overview of the partners. So as I said, there's Jülich is the coordinating part, but you see there's a whole range of different partners here. Supercomputing centers, some other funding bodies in particular, and some other research bodies like CEA in France, and several universities, of course, are involved in this one as well. So the Deepsea has a broad set of work in the software system. So Deepsea targets really the core of the software stack, and to build this up to kind of fit together at a very high technology ready level that we're trying to achieve. So we have a fully forming software stack. So it's very similar to the ST activities in the ECP project. There's areas on performance monitoring on tools, It starts with tools like Scorpion, Scalaska, which have been developed by Jülich for a long, long time and have been highly successful. Perhaps for the DOE, some name that rings a bell is MemAxis. We're going to take MemAxis and extend it. There's a tool to kind of visualize memory transfers or in general data transfer within systems, which of course becomes very important as we scale, and also as we have multiple technologies put together. So we're going to take that and then of course also contribute that back to the open source software stack. There's a tool called DCDB, which is a large scale monitoring infrastructure, which we're going to extend. And Profit, for example, is a prediction tool, is a modeling tool out of Barcelona to understand impact of new memory technologies. There's work going to be on on-node programming models, a lot of stuff through OpenMP, but also work on OMPs through the Barcelona Supercomputing Center, focusing on a particular task support, a particular support for high performance data analytics code and what's needed there to drive the special needs of these codes with a higher IO ratio, and also with a more flexible or more dynamic execution environment, and also some more high level programming approaches from ETH. So if you watch the Gordon Bell paper from last year, you can get an impression of where this work is going. We're looking also at off-node models, and also going to come back to that a little bit later through both MPI and GASP. And then there's also work on the operating system, kind of extending resource management, working on Slurm, and also integrating with the new PMAX standard, and then kind of driving this part forward as well. So you see there's a whole range of activities that will go on here, covering the whole software stack. There's of course a lot of open source technology we'll take in, and there's a lot of we're planning to put together to put out in the community again as well. And then what I don't forgot to mention, of course, we're going to look about integrating new memory technologies as well. So what does NVRAM, those byte addresses at VRAM, for example, does for us here, and how can we integrate this into something like OpenMP, into something like MPI or GASP. The focus is on heterogeneous systems. I think everybody expects by now that if we go towards Exascale and beyond, we'll have some form of heterogeneity in the system. Before we look at both types of heterogeneity, there's integrated systems. So there's a picture, a public picture from the EPI that shows kind of the idea of these tiled architectures, where you have some ARM chips connected with some accelerator chips, and you can kind of have this integration within there, but you have heterogeneity within the chip potentially, and can use and can find out how to use this most efficiently for your application. And then also there's heterogeneity across systems. If you take multiple clusters, different cluster modules, each with their own architecture, and put them together and connect them, you can also here try to specialize for a particular application, try to use the right hardware for the right application. So this kind of runs under the banner of modular system architecture. The system is an idea that was driven by the DEEP projects from Jülich for a long time. We're going to look at both of types of these heterogeneous systems and adapt the software stack to that. This is a picture of the overall architecture of Deepsea. You see this typical software stack where we're interfacing to the EPI on the bottom. We have the European applications here on top. We're integrating to other software projects. So there's two more C projects. There's an IOC for IO performance, and there's a Red C for networking. There's also Regali, and you get to that in 1 second. You see some tools here in the middle, some on-node models, and some cross-node models, which we dubbed as cluster models. And in particular, in the cluster side, what we're going to focus on, and particularly focus on the research at TUMAD, is malleability. So how can we actually have a flexible software stack where we can grow applications, shrink applications based on needs, based on efficiency constraints, and how can we bring this to the user in a way that is easy to use, but at the same time exploit the efficiency on the underlying system. And then of course you want to connect to international efforts as well, and I think that's also where the efforts of E4S would fit in very nicely. I've listed here for now ECP and the Fugaku work, but I think the E4S is also a very natural intersection point here, particularly when we talk about the open source components of the software stack. So I said already, the core theme in the cross-node programming models is malleability. We want this adaptivity to get better resource utilization, to find out, for example, in point of power, direct the power to the right parts where we need it, to utilize the existing memory, for example, a little bit more as well. We have variability on the systems. Also here, we need adaptivity to kind of counteract this variability. We will not get a lockstep system anymore. And the same thing also counts for complex workflows. And last but not least, we want to support new types of workloads, particularly some of these machine learning and high performance data analytics workload really need a much more flexible model, a much more dynamic model. And the question is, how can we support this coming out of traditional HPC models, which we know give you the performance, and we want to see how we can bring these two things together. And that includes the whole resource management, of course, from the hardware, the middleware, all the way to the application. And that, of course, includes MPI as well. And so we're working on new concepts in MPI to drive this malleability forward. And if you followed MPI a little bit, there's a new concept called MPI sessions that was introduced just recently that will be in the new upcoming MPI 4.0 standard, which is not malleable by itself, but provides a whole new view on how to look at resources in MPI and allows you to do better malleability there, particularly if you start integrating it with resource manager and extensions to resource managers. And there we're looking in particular in working with the PMAX standard community to expand the standard to make this work and to have this interaction between the programming model and the underlying resource manager. And also we hope that we get out of this almost naturally some kind of more dynamic resilience out of that, because shrinking an application, particularly shrinking an application on the spot is the same thing as tolerating a fault. And so we hope we can work with that very well. And we're also looking at integrating this into other EuroHPC projects. And I get back to this towards the end of my talk. So this was the first effort. There was Deepsea, so the core software stack, typical programming model work, tools work to kind of get these the user support on these systems that we need. And I want to talk about a second project called REGALE, which is complementary to Deepsea. This is a second project with a different set of partners that we're doing, which looks at this whole thing a little bit at a higher level and more on the holistic side, through a more holistic resource management that looks at performance, power, energy, and throughput, and tries to balance that kind of based on a policy-driven approach of what you want to do with the system, and then tries to execute HPC applications on that system, but also machine learning and data analytics applications on the system in an energy efficient way, but trying to balance these resources in the right way. Also looking here at an easy composition, of course, so we can deploy this on architectures better, so we can be flexible. And the core part is really a continuous monitoring. We're looking at very sophisticated monitoring technology, like we have already with the DCDB set, where we can take up sensors from of these thousands, if not millions of sensors we have on the compute system, try to understand them, try to get some analytics on them, and with that then drive the systems. So this is kind of the high level approach. My apologies, this is actually still in German, but I think most of the things translate fairly easy into English. So we have the applications, we have the nodes, and we have the system on one side. We measure a lot of stuff on these systems through our monitoring infrastructure, and then have the appropriate managers at the appropriate levels to control, to pull the right knobs, and with that again to optimize. And we get this feedback cycle in the system to hopefully get it to a very efficient system execution. Again, large set of partners here, and even more partners than we had in Deepsea. Again, you see a very good mix of compute centers, of research institutions and universities, and also some companies involved, like for example Atos up here, and E4, which is an integrator in Italy. So you see there's a lot of work going on in here, and a lot of work between partners. This is a strawman architecture, also not too surprising. Unfortunately, again, at the moment, very high level because we're just starting the work. But you have a typical software stack, and the E4 and the Deepsea software stack would fit here down here. Then we're monitoring this whole thing. We're doing this in a long-term monitoring database that we can, at selectable granularity, store this data, have historical trends, and we can give this out to the node managers, the job managers, and the system managers. We're connecting this to the appropriate workflow engines, of course, as well. And then the whole thing, the idea is this whole thing be policy driven from the site administrator that can fine tune the needs of the system based on the needs of the center. And then these optimization will trickle down into the infrastructure and hopefully execute the system in the right way. And this is, of course, very closely connected with some of the work we've been doing for quite a while now on the power stack. You're creating this global power stack. We want to apply this to the system. In one instance, of this REGALE system will be this power stack where we control the power at node level, at job level, at system level, but also do the right system design around it to get this 3-tier system connected to the resource manager and steer the power in the right way. This, of course, then is then a question of getting the right interfaces and the right resource abstraction done, but this will be part of the work. And we will do this work very closely with the Power Stack Initiative, which probably some of you have heard me talk about, which is an active international initiative where we try to find commonalities in these power stacks, which are always slightly different between system and system, between centers and centers. We want to identify common terminology, components, and site-specific policies, so we can create this ecosystem. So again, very similar picture where you're at the node level, you control power at the node level so you don't have burnouts, you power at the job level so you have efficient execution, you control at the system level so you have site policies that, that can drive that, and the right communication between them. So this Power Stack is an initiative that has been started in 2018. We started at this wonderful location on the Bavarian countryside with about 40 people. We had 4 of these workshops since then. The last one, unfortunately, had to be virtual, but we had a virtual workshop in 2020, as well as sessions at major conferences. So this is an active collaboration that has been driven forward and also will help frame what's going on in the REGALE project. And there's also work at Lawrence Livermore, but Barry Roundtree and Tapasia Patki, who work with us very closely in this and will help us to drive this forward. So what's missing, of course, now is we have this really great software stack. Of course, we want users for the software stack. And so also here, there's going to be a set of projects that deal with applications. And I want to just pick out one again, because we are involved in that. And it's the one I can talk about right now. This is the Timex project, where we look at parallelization across time and as a technique to get more parallelism out of the code to kind of increase the level of parallelism in the application so we can exploit these highly parallel systems. Also, this is a large scale effort, a little bit smaller than the other ones, but nevertheless, 4 countries involved, 10 research group. You see the markings on the right side on the map. So this kind of more Central Europe, but nevertheless international here. Several target applications as involved in well, from weather, climate, medicine, and electromagnetic and drug design. And then, of course, there's a lot of collaborations going on in this project as well to kind of make this technology available worldwide and kind of integrate this into the software stack. So how does this fit together now with the other ones I've talked about? Well, there's 2 fundamental challenges that we have when you look at this parallelization over time. There's a varying efficiency because the convergence can change over time. And then also, if you look on the provider side and supercomputing center side, getting a large allocation for this is always kind of tricky. And particularly if you have this varying efficiency. So the idea is here of Timex to explicitly work together with the work that we have in Deepsea to kind of make use of this new malleable MPI and to kind of work kind of on an interface between an application who has varying degrees of parallelism and then a system, including an MPI, that can provide this. And so we can negotiate resources in the right way. Of course, this has to be done across the whole system to make sure you have a fair resource allocation as well. But this is really an application that can benefit from that. And so we're going to do support varying resources for parallel time applications. With the changes to MPIs, there will be a co-design between what's happening in Deepsea on the MPI part and on the application side in Timex. And of course, the idea is to kind of push this also forward to other applications as well. But the idea is kind of you can overlap iterations in the right way, do the use of this particular techniques in Timex, and you can kind of grow and shrink the number of processes you have. Basically, you're just changing the amount of overlap with that. Of course, you always have some efficiency losses there, but you can make use of some of the resources and find the sweet spot for a particular setting, for a particular application input set, and then negotiating that with the MPI. This will be kind of the interesting research part that we're trying to achieve in this project. So overall, I think hopefully I gave a first glance in what's going on in the EuroHPC activities. It's kind of driving the R&D towards European Exascale, and of course beyond that as well. We're not just looking at Exascale, we're looking also at what's going on afterwards. There have been recently 14 projects funded in the software areas. There have been 5 more projects in other related areas funded as well. The target start date for most of these activities is January 1st, but that time will hopefully also have a public presence of all these projects with a public description of the partners and all the activities which are going on that. I could only talk about 3 here. One is the Deepsea project, which integrates provides an integrated software stack from the operating system, the necessary exchange programming models and tools. Of course, we're not going to develop all this from scratch, but if we take a lot of in from the community, we hope to work with the community and then make the specific extensions that we need and then give this back to the community. There's a focus on malleable MPI, particularly on our side we want to do. We're going to work very closely with the Timex project to kind of make this technology work and kind of see how it works for applications. And then last, the second project or the third project I've been talking about is the REGALE, which allows you adaptive resource management through this continuous monitoring and control loop. We do the appropriate workflow management as well. And our particular part, again, from LRZ and TUM here, is to work on the energy efficient operation and use this control loop to implement such a power stack which can react to the right power and energy requirements. And many of these contributions will be open source. There are some companies involved, so not everything will be open source, but definitely everything that comes from the universities will be open source. We're really looking forward to the right collaboration opportunities with other parts of the community like E4S. I think this is a great effort, and I'm looking forward to working with all of you. Thank you very much, and hope we still have some time for 1 or 2 questions.
There are some questions, at least one in the chat. Martin, I don't know if you can, I can read it to you. It's actually from me, but
okay, go ahead.
Question is, what are some first steps for exploring collaborations, and what might be some impediments, technical or otherwise, to those collaborations?
So the first steps is, I mean, if you're particularly looking at the Deepsea plans to kind of design the core pieces of the software stack in the very early months of the project. And I think this will be a very good time to engage, to make sure we're not reinventing the wheel. We kind of use things that are already in the community, in particular through established projects like ECP, E4S. So I think it would be very good to engage, just to compare notes in the beginning. I think that would be very helpful. Impediments, I personally don't see that many, to be really honest, particularly on that level. I mean, as I said, there will be some, there will be some commercial interest, of course, involved as well. And those, of course, we will have to tread carefully around, but a lot of stuff will be open source, and there's certainly the plan to contribute to the international community, even though the word Europe is in a lot of different things here. Mike, does it explain? Does it help?
Yeah, that helps a lot. Thank you. Taking notes. Yeah.
If you would please take some time to answer the other questions in the chat window later.
I will certainly do that, yes.
And our next speaker is Dr. Todd Gamblin, who is a computer scientist in Livermore Computing's Advanced Technology Office at Lawrence Livermore National Laboratory. And he will be giving a talk on SPAC and E4S. Todd?